This is Chapter 1 for 1342 on data collection. There are 6 sections in this chapter. It's the most sections of any chapter. The first section is just the introduction. That's mostly vocabulary. The second section is just the difference between an observation and an experiment. The third one is about simple random sampling. And the fourth one is about other sampling methods. So those kind of go together. Then section 1.5 is on bias in sampling, and that's going to be relatively short, not much there. And then the last section is about experimental design. So the first thing they talk about in this textbook, and it's on page 6 of your textbook if you'd like some more details, is the process of statistics. It is a 4-step process. The first step is to identify the research objective. So what do you want to study? What are you trying to solve? What are you trying to figure out? What question are you trying to answer? So the researcher must determine the questions they want to answer and be detailed enough so that the population to be studied is identified. We don't focus on this first part of the process. This is more for graduate school when you're doing your own research. Then you would come up with your research objective. The second part of the process is to collect your data, which is what the rest of this chapter is about, collecting your data. So we're going to talk about conducting a proper sample, and if we don't do it right, then our conclusions are meaningless. So this process will be discussed throughout the rest of chapter 1. After that, we talk about describing the data. And this is when we start to summarize and organize to help us kind of see what our results say. So we're trying to get an overview of the data and come up with some statistical methods to use to make some conclusions. So chapters 2 through 4 of this textbook are about describing the data. And the big part of statistics, the fourth part, is to perform inference. That is really where the most of the statisticians spend their time, is performing inference. So we're going to learn a couple different techniques about how to extend our results from the sample to the population, and we'll discuss the difference between those. We also want to think about how reliable our results are. So reliability will be discussed in chapters 5 through 8, and then inference. The book continues from chapters 9 to 15. We stop at chapter 10. So this is kind of the big overview of the entire course. We start with collecting data properly, then we learn how to describe the data, then we perform inference. So that's kind of the whole statistical process. There's an example in your textbook. It's about gun ownership. And so this is a poll from 2010 about how Americans feel about the existing gun control laws. And it just describes the statistical process to help us work through the situation. So it's broken down into 4 phases, and every survey and experiment can be broken down into these same 4 phases. So there's some homework problems that will help you break down the different phases of the statistical process. So in this situation, we have identifying the research objective. They want to determine the percentage of adult Americans who believe gun control laws infringe on the public's right to bear arms. So they're focusing on adult Americans. The second part of their process is to collect the information, collecting the data. So it's unreasonable to expect to survey everybody. There's over 200 million adult Americans, so we're not going to survey everybody. They surveyed a sample of 1,007 adult Americans, and they got the results that 514 believe that the existing gun control laws infringe on the public's right to bear arms. So they gathered the data with the sample and got their results. With those results, we need to be able to describe the data to summarize what we came up with. So they decided to do 514 out of 1,007 to come up with their percentage of 51%. So this is what they call descriptive statistics. And finally, the last part of the process, the biggest part, is to perform the inference. So they want to take their sample, the results of their survey, and extend it to all adult Americans. So when we're generalizing, our results are not exactly perfect. So they come up with what's called a 3% margin of error. We'll discuss that in Chapter 9. So they feel fairly certain, a specific percentage of confidence, that all adult Americans who believe these gun control laws infringe on the public's right to bear arms is somewhere between 48% and 54%. So they took their sample and subtracted 3% and then added 3%. That's their margin of error to allow for some wiggle room, that the true percentage is somewhere between 48 and 54%. So we're extending our sample to the population. So that's the whole statistical process. We're focusing on the process of 2 through 4. The research objective will already be determined for us. So the definition of statistics is in 4 parts, which should be fairly logical based on the process of statistics. And so we have collecting, the science of collecting, then organizing, then summarizing, and finally analyzing information to draw conclusions or answer questions. And in addition, it's about providing a measure of confidence in any of these conclusions. So we want to be confident in our results. So collecting, organizing, summarizing, and analyzing. It kind of follows the process of statistics. So the rest of this section is about a lot of different vocabulary, and we're just going to kind of go through each set of vocabulary. They're kind of grouped together, and I'll explain as we go. So the first vocabulary word is about the entire group to be studied, and we call that the population. The population. Then we have a subset or a smaller set of the population to be studied. That's what we call our sample. And finally we have a person or object that is a member of the population, and we call that an individual. So the population is everybody, the sample is a subset or a small group of those people, and the individuals would be those individual one person or one object that we're studying. So those 3 words kind of go together: population, sample, and individual. The next 2 words go together as well. So a numerical summary of a sample versus a numerical summary of a population. So a numerical summary of a sample is called a statistic, singular. A statistic is a numerical summary from a sample. And then a numerical summary from a population, we call that a parameter. A parameter. So a statistic and a parameter are both numerical summaries. One's from a sample and one's from a population. The easiest way to remember that is that statistic starts with an S, sample starts with an S, parameter starts with a P, population starts with a P. To me, that's the way to remember the difference. Then we have the 2 different types of statistics that we've already kind of discussed. The first one is called descriptive statistics. So this is where we do the organizing and the summarizing. That all falls together in descriptive statistics. So we have numbers that we can organize. We can organize things in tables and graphs, and that'll be in chapters 2, 3, and 4. And then the other part of statistics is inferential statistics. And these are methods that take a result from a sample and extend it to the population, and also measure the reliability of the results. So that'll be chapters 5 through 10 for us. So the 2 branches of statistics. Then we have different types of data. The first type of data we call qualitative. Look at that spelling. Qualitative, sorry. And they're called qualitative variables. So qualitative variables allow for the classification of individuals based on a characteristic. So these are also sometimes called categorical variables. We can put them into different categories. And averaging these values would not make sense. So these are different descriptors such as hair color or favorite color or location that just doesn't make sense to average anything. These are categories, not numbers. And then we have what are called quantitative variables. And these are for numerical measures of individuals. And averaging these values does make sense. So height, weight, age, any kind of numerical measure we can think of, that would be a quantitative variable, where it would make sense to average. So we have qualitative, and when I see that word, I think of the word quality. So the quality of someone is a descriptive variable. And then quantitative, I think of the word quantity, which is an amount or a number. So that's the difference. We're using the word variable here, very different than how you've seen it maybe before in an algebra-based course. So for our class, when we say variables, we're not talking about letters that represent numbers. We're talking about characteristics of individuals within the population. So it has nothing to do with the algebra definition of variables. So height, weight, hair color, all these descriptors we can use to describe someone or categorize someone or measure someone, all of those things we're going to call variables. So very different than an algebra course. Finally, we have two types of quantitative variables. So quantitative variables or numerical variables have two different types. The first one is called discrete. And these are quantitative variables that have a finite number of possible values, or what the book calls a countable number of values. It usually answers the question, how many? How many people, how many objects, how many shoes, how many whatever. So it's a countable situation. And then we have quantitative variables that are continuous. Continuous quantitative variables have an infinite number of possible values that are not countable. These are usually measurements, such as how much weight, how much height, how much speed, volume. All these measurements are continuous. They can take on an infinite number of possible values. So there are discrete quantitative and continuous quantitative variables. So this first section is a lot of categorizing. Is it this or is it that? Back and forth between two options. So I have a few sets of examples that kind of classify different situations into one of the two categories. So the first set is the difference between a parameter and a statistic. So is it a parameter or is it a statistic? And so here are some examples. This says only 12 men have ever walked on the moon. Their average age at the time of their moonwalk was 40. So that's for all the 12 men. That's the entire population. Remember, parameter comes from a population, and statistic comes from a sample. So the sample version of that is in an interview with 5 of the men that have walked on the moon. Their average age was 45. So that's a sample of 5. So that's the difference between same situation. This parameter is referring to the entire population. This is a statistic just referring to that sample. So similarly, we have Ty Cobb, who has a career batting average of .366. That's all of his games. So that's his population, all his games. versus if Ty Cobb had a batting average of .240 in 41 games. So that's a sample of just 41. So same situation, one's referring to a parameter and the other one's referring to a statistic. Again, we have it is known that 49% of all students on campus own a car. That's everybody, the entire population of students. Over here, in a sample of 100 students on campus, 46% of them own a car. So you see the word sample, which should hopefully help you remember statistic. A couple more. It says 12% of the 50, so of the 50, we know we have 50 states, so 12% of the 50 governors of the United States are female. So a couple giveaways. The word "the" helps, and also we know we have 50 states, so that's the entire population of governors. Versus over here in a sample of 30 states, 20% of the governors were female. So the word sample gives it away, and also there's 30 instead of 50. And finally, the average score on the departmental final exam is 72% for all students enrolled in Calculus 1 on campus. Over here, the average score for the departmental final exam in a sample of 50 students on campus enrolled in Calculus 1 is 65%. So we have a statistic and a parameter. One's referring to the entire population, one is just referring to the sample. So hopefully those examples make it clear what comes from a population, what comes from a sample. All right, the next distinction we're going to discuss is qualitative variables versus quantitative variables. And those words can end up looking the same, so look for the L or the N if you're having a hard time seeing the difference. L or N, qualitative versus quantitative. So remember, qualitative is a quality, quantitative is a number, or sorry, quantity. Quality or category, quantity or number. All right, so here are some qualitative examples. The brand of phone owned by students, so different brands of phones would be different categories. The birth month, what month you were born in, is a different category. Your gender is a category. The state you were born in, if you were born in the U.S., the state you were born in would be a category. Your favorite food would be a category. And finally, zip code. Zip code's a little tricky, but a zip code is just a classification. It's not an actual numerical measure of anything. It does not make sense to average zip codes. You wouldn't say the average zip code in the Houston area is a number. It wouldn't make any sense. So zip code is a classification. It does not make sense to average. So if you're kind of stuck, zip code is a tricky one, and so is area code. So the area codes in front of phone numbers don't make sense to average either. You wouldn't say the average area code in Houston is a number. That wouldn't make sense. So area code is another classification. Then we have quantitative or numerical measures. We have points scored by a player in a basketball game. That's a number of points. Concentration of a contaminant in a water sample. That's a measurement. It would give you a number, usually in parts per million or parts per billion. Goals scored by a team. So again, we're looking at the number of goals the team scored. Height is a measurement. Measurements. The number of students who passed the first exam, that's a count, how many passed. Temperature is another measurement. These are all numerical, either counts or measurements. And finally, the cars through the drive-thru at Whataburger between 12 a.m. and 1 a.m., they would be counting the number of cars through the drive-thru. So quantitative variables are anything with a number. All of these make sense to average. So it makes sense to average the number of points scored by a player in a game. It makes sense to have an average concentration, an average number of goals, an average height. All of these it makes sense to average. Over here, it does not make sense to average. So whatever you can do to help distinguish those two, there's a difference between qualitative and quantitative. Now within quantitative, there are two different types, and you might have kind of started noticing that through the list. There are two different types of quantitative variables. So we'll look at that next. We have discrete, and then we have continuous. So discrete, remember we said is countable, and continuous is a measurement. So these are the same examples, but separated between discrete and continuous. So the number of points scored is a count. The number of goals scored is a count. The number of students who pass the first exam, that's a count. And the number of cars through the drive-thru is a count. These are all countable things. Measurements would be like the concentration of the water contaminant. You couldn't count that. You'd have to measure that. Height, you don't count height, you measure height. And again, temperature, you don't count temperature, you measure temperature. So you'll have to distinguish between discrete quantitative variables and continuous quantitative variables. The last thing in the first section is about different levels of measurement. I am not going to test you over this. There might be a homework question over it. So if you refer to page 10 in the textbook, it describes the level of measurement, but it's not something I'll be testing over. So that's it for section 1.1. Now we'll look at section 1.2. So section 1.2 is about the difference between an observational study and a designed experiment. And the titles kind of give it away. It should be relatively clear. I'd like you to read through this scenario about cell phones and brain tumors. Just kind of read it to yourself. I'll give you a minute. So this was a study done, and they did a lot of categorizing. They were matching people up based on age, gender, region. They were also matched about their demographic background, their cell phone use, their medical history, and their smoking status. And they found no difference in cell phone use between the two groups. The key word I want you to find in this paragraph is that the individuals were interviewed, and they were just learning about past mobile phone use. They didn't have them do anything, they were just observing and recording. I'd like you to now read the second cell phone scenario. I'll give you a minute to read the second one. So as you're reading through it, they're taking rats, they're dividing them into 3 groups, and they're exposing them to different frequencies. So these rats are getting exposed to different frequencies, and they had a control group that didn't have any exposure. So they're doing this exposure and measuring the outcome. So they just did the research and then came to their conclusion that they found no statistically significant increase, which we'll discuss down the road in chapter 10, between the different groups. So if you look at the 2 scenarios, the first one, they were just interviewing Nothing crazy going on. They were just interviewing some individuals and getting some data from them. In the second one, they're running an experiment with these rats. They're dividing them into groups. They're exposing them to different levels of radiation. So they're doing something to the subjects versus just interviewing them. So hopefully that makes it clear the difference between an observational study and an experiment. So let's kind of discuss some of the key points that are different. In an observational study, no attempt is made to influence the individuals in the study. They didn't expose them into anything. They didn't ask them to do anything. They were just interviewing them. So in an observational study, we measure the value of a response variable or an output without attempting to influence the value of the response or the explanatory variable. And I'll discuss those words in just a minute. So nothing's being done. It's kind of a hands-off approach. We're observing. In the design experiment, this is the one with the rats. This was very hands-on. It was intentional. So each group was intentionally exposed to different levels of radiation. And the researcher assigns the individuals to a certain group and then intentionally changes the value of the explanatory variable and then measures the response variable. So he's changing something intentionally. So hands-off versus hands-on. So there's some new words in here, response and explanatory variable, so we'll go ahead and discuss those next. So the values of the manipulated characteristics is what we call the explanatory variable. If you've taken an algebra class, this is the x variable. We also call this the input. Then we have what's called the response variable. And this, in algebra, we call this the y variable. It's the value being measured as a result. So result or response. And I always think of this as the output. So our input is our explanatory variable, or x, and our output is our response variable, or y. And so the goal in running any experiment or doing an observational study is to determine how varying the amount of the explanatory variable affects the value of a response variable. So if you've taken a science class or you've done science labs, even back into grade school, you're changing different inputs and measuring the outputs. You might be changing weights or colors or chemicals or who knows, anything that you're changing and tweaking and then measuring the response variable. That is running an experiment. Alright, so there are some pros and cons of both observational studies and experiments. The book doesn't get into these as much. I just think it's important to kind of talk about the difference. So some pros for observational studies is that they're easy to implement, they're less expensive, and they're generally low risk. We're not hurting anybody. We're generally just asking questions or measuring something without changing anything. It's also less time consuming. So that kind of goes with less expensive. Companies call it less expensive if it's less time consuming. One of the biggest cons to an observational study is something called confounding. Confounding.